Good afternoon, everyone. Welcome to the Sharjah Academy for Astronomy, Space Science and Technology. So this is one of our regular general lecture that we have the Academy every or around 2 weeks. So this is the last one for this year, 2021. It is an excellent one. I'm sorry. Getting the flu, maybe getting COVID, whatever. So,
سلامات يا دكتور.
Allah يسلمك إن شاء الله. So today, Mr. Amr Ansari, he's our SAASST Planetarium scientific guide, is going to present something very, very important related to Mars, because as you know, so the UAE is very much interested into Mars exploration. So we have the Mars formation right now going around Mars, and hopefully by 2017 we're going to have this Martian habitat. We'd like to go there, to live there, but we would like also to go there and live there peacefully and also comfortably. But now Mars with its very, very thin atmosphere, so it will be impossible for us to go and live just like that. So we need to be specially protected within our habitat. So I'm going to tell us how can we transform that? How can we render Mars livable like Earth? That's why this beautiful poster that you see in front of you, it is half Mars, half Earth, is what we should do in the coming future. So we welcome Mr. Amr. So please, Amr, you have the stage.
Thank you, Doctor. Thanks so much for everyone who comes to this lecture. Hopefully, I be a light guest. And so, as Professor Elias mentioned, now Mars is so important for us as human beings here on Earth. For a long-term plan, we need to search for another place to avoid many risks here on Earth. So, how to transform or to make Mars a habitable place for our life? That will be our topic today. But before terraform Mars, we need to understand many things about Mars first. Of course, we will return back to we shall start from our planet Earth. So let me start directly to the presentation because I have many slides. The first question is that I want to ask myself, why do we have to look for life outside the Earth? Why? I think it's not comfortable to live on a place wearing all the time spacesuit and to live in doom. The air there is unbreathable, and there is no temperature and many challenges on Mars. So why do we want to go there and to live on Mars? What about Earth? Of course, we have our planet here. We have everything we need. We have a unique planet full of oxygen, water. So we live in prosperity here on Earth. So why do we think to change our place? Actually, if we think like this, if we say that, okay, let's live here on Earth, do not think about any other place in the solar system, but we have many risks here on Earth. We have what we call it global annihilation risk. And one of the first of these risks actually that threaten our existence here on Earth is the nuclear war. As you know, now we have 9 nations who have nuclear weapons, like Russia, for example, United States. Of course, the situation is stable. It looks stable between USA and the Russia. But look at the tension between Pakistan and India, for example. And what will happen if we repeat this disaster again after the World War II? You may remember Nagasaki and Hiroshima and what happened for them after 2 nuclear bombs were sent over them. So let's tell you about the casualties that we have we have more than 170,000 casualties. And of course, the victims is more than this number. We are talking about a nuclear weapon, like more than 70 years now, where the nuclear technology was just in the beginning, it was primitive. So in terms of destructive power, we have now nuclear bomb that is like 1,000 times more powerful than the one which sent on Nagasaki or Hiroshima, the little boy, for example. So any nuclear war that happens this day, it will disaster, it will vanish all of the living things on the planet Earth. And we have crazy people here on Earth, so do not trust anything, or why they still have warheads and why they still improving their nuclear weapons. Another risk that might happen, and that happened for on our planet, like asteroid impact or any object that might come from the outer space. If we have something like that, if we have an asteroid which is massive enough, it will cause a disaster. It will burn everything, so our planet will not be available for us anymore. We can remember 65 million years ago and what happened in the era of the dinosaurs at that time. More than 70% of the living things were damaged. A new virus, like the one we have, the pandemic, as we have now, that also like just yesterday, the number of deaths, like more than 5 million. Fortunately, we still uh, pretend that we have the control or we can control that. But you could imagine what will happen if we develop that as a weapon. So what will happen at that time if we lose the control on the tiny biological viruses as we know. Climate change, this is one of the fundamental issue here for our planet. Climate change, we don't mean here that climate change means the hot regions will be cooler or the cold regions will be hotter. Actually not, but climate change is a fundamental because look at the climate itself, it is unstable. Once we see like fire everywhere, ice melting from the pools, and the temperature of our planet is getting higher each year. So you may have seen also the I think 20 countries have had a meeting between each other to find a solution for the climate change. If we are talking about Earth after 100 years from now, look at the amount of carbon dioxide that we have from factories, from huge factories. So what is the fate of our future here on Earth? So we have also climate change as a very fundamental risk that will threaten our existence. Also, artificial intelligence going wrong. This one you may haven't seen or haven't heard about this one before, but you can imagine now we are developing robotics, and like what will happen if we develop robot as weapon. Now we can control that by programming, but what if we lose even the programming? What if somebody can use it as a weapon? Of course, that also will cause a disaster for our existence on Earth. Population, the world population is going very, very high. So we have this chart, for example, that will explain the world population in the last 50 years. We were 1950, we were like 2.5 billion, and now we are about to be roughly 8 billion of people. After 100 years, at 2100, it will be 11 or 10.5 billion of people. So how can we feed them? We have limited resources, as you know. So how can we feed them? The war in the future will be I don't know, maybe we will fight each other for a drop of water, even if we will not develop and innovate any methods to in agriculture and to develop the resources that we have here. We are talking about 100 years from now. So what about 200 years, 500 years, let's say 600 or 700 years from now? Look at the future of our planet, how it will be. For that reason, scientists actually started to think about living on one of the objects in the solar system. So we checked all of the objects in the solar system. That's why space exploration started like 70 years ago to look for another place to send humans there and to colonize that place. Of course, we have Earth, we have Venus and Mars, but let's start with Carl Sagan. Carl Sagan, one of the famous astronomers, who wrote in 1961 an article, and that time he was talking about how to colonize Venus. So Venus at that time actually was the bright vision, the bright project for us, because it is very close, and we thought that Venus has atmosphere and maybe it has oxygen, so we can deal with that. We can travel to Venus at that time. But after that, he wrote a paper, another paper in 1996 about Mars as a possible destination for humans, and he started to mention many reasons to go to Mars. So why Mars? Why Mars? As you know, we have many reasons to take Mars as target to colonize the planet. As you know, Mars is the most accessible place in the solar system, and it may give us the opportunity to answer some of the fundamental questions that we are looking for. Questions about the origins and the evolution of life. And one day Mars could be that destination. Scientists also, as you know, have been trying to explore the possibilities of life. How many missions have been sent to Mars? Roughly 56 missions have been sent to Mars. Unfortunately, 26 only have successfully reached Mars between landers and orbiters, like Space Hub, for example, that has been sent from UAE, which has been operational by UAE here in our country. So we are trying to explore Mars. We are trying to prepare ourselves to travel to Mars. But of course, we will travel to Mars according to the data which is being received from the active missions. Mars is not a place where we can live. We have many challenges. We have challenges of the air, the atmosphere, the gravity, the amount of radiation, and the amount of water, and how can we sustain there for 2 years? Because if we go to Mars, it means we have to stay there for 2 years until any mission could come again, or even for the mission to get back to Earth. So if we travel to Mars, we will not come back to Earth unless 2 years passes. So this is the question: how to go there, and how to sustain, at least in the beginning, for 2 years, then forever. So we need to know some facts about Mars. Let's take a quick look at some facts of Mars in terms of size. The size of Mars is about half the size of Earth in terms of the diameter. In terms of weight, it's about 38%. So, for example, if you weight 100 kilograms here on Earth, it will be like 38 on Mars. The day is a little bit longer. 40 minutes is longer than the day on Earth, but 1 year on Mars equals 2 years on Earth, because of course the orbit is a little far away. See, this size, you could fit more than 6 Mars to fill the volume of Earth. In terms of temperature, which is very essential, temperature on average, it is very cold. The temperature there, the average is 60 minus 60 degrees Celsius degrees, which is for us, it's impossible to live in this very cold environment. Mars inner structure is very important also because it can tell us many important things. Look at Earth. Earth has a very active core, and that core which generates the magnetic field or the protective magnetic field that protects us from the radiations that come from the sun or even from the outer space. For Saturn, for Mars, the story is completely different because it has a core, but it is dead. The active core is shut down maybe billions of years ago. That's why Mars has no magnetic field. That is very important if we want to live there, if we want to make rehabilitation for Mars. I think we should consider the magnetic field of Mars, the very weak magnetic field there. We will talk about this in details. The atmosphere of Mars, mostly carbon dioxide, 95% or 96% carbon dioxide, less than 2% argon, less than 2% nitrogen, and very little amount of oxygen and other gases, less than 1%. So let's get back in time. Let's see the history of Mars. We now believe that one day Mars had a thicker atmosphere with water, liquid water on it. The water, or we have some proof that liquid water existence flowing on the surface of Mars one day. But what happened, no one knows. Many gases escaped. This is very important. When you say gases escape, how that could happen? Many gases escaped from the atmosphere of Mars, but CO2, carbon dioxide, is still there. It is dominating, and efforts from different scientists from different space organizations are trying now to find what happened to the thicker atmosphere of Mars that Mars had, of course, in the past. The answer will take, of course, a little quite, let's say, like 10 years maybe or more. We have this the Valley of Mariners, or the Great Canyons. Look at the Great Canyons. We believe that here some signs of liquid water that existed one day, like millions of years ago. But the question now that we will try to answer, how the atmosphere became thinner. That's very important. Let's say if we try to make Mars habitable by any methods, but Mars used to have everything that we want, like thick atmosphere, oxygen, liquid water, and so on. So before make the Mars terraforming, let's understand what happened to Mars and what caused the atmosphere or the gases in the atmosphere to be driven away or to escape from the object or any object in the solar system. So we will explain that, or we'll try to explain that. Atmospheric escape, what causes atmosphere to escape from any object? Escape occurs when molecular kinetic energy overcomes gravitational energy. How is that? In other words, a molecule can escape when it is moving faster than the escape velocity of the planet. This is very important. For example, here on Earth, why we cannot have hydrogen, for example, because hydrogen has the velocity which is higher than the escape velocity of our planet Earth, which is 11 kilometers per second. If you want to launch a rocket to travel to the moon, for example, or to go to Mars, that should exceed 11.2 kilometers per second. For gases, it's the same. If any gases exceeds the escape velocity of that object, so it will be driven away. It will escape from the gravitational pull of that object. We have many mechanisms that can explain how atmosphere can escape from or how gases can escape from any atmosphere. The first one, we have the thermal escape. Three factors strongly contribute to the relative importance of Jeans escape. Jeans actually is one of the famous astronomers, and he put down this idea, and he explained in details how gases can escape from the atmosphere. He talked about the escape velocity of the planet and how the upper layers of the atmosphere can be heated by the sun's heat, how that could affect on the gas on the upper layers of the atmosphere, causing them to get kinetic energy, high kinetic energy, to overcome the gravity, and in this case, they will escape. The second mechanism we have called hydrodynamic escape. In this mechanism, an atmosphere with high pressure and temperature can also undergo hydrodynamic escape. In this case, a large amount of thermal energy, usually through extreme ultraviolet radiation, is absorbed by the atmosphere. So how that could happen if you have a protective shield of magnetosphere? Fortunately, here on Earth, we have it. We have the magnetosphere, or the magnetic field, that protects us from ultraviolet. But there are some regions in between the magnetic field lines that can let the ultraviolet to pass and affect on the gases there to let them to escape from the atmosphere. We are talking about Earth, that's fine, but what about Mars? Mars has no atmosphere, so ultraviolet finds its way easily to hit or to strike the Martian surface or the Martian atmosphere. By this way, gases will escape because they will get energetic. Lighter molecules can drag heavier molecules with them through collisions, because collisions between molecules, they will exchange energy, so the slow will becomes faster, and so on. We have an example for that, for this mechanism, hydrodynamic escape. We have this 51 Pegasi b, one of the hot Jupiters, we know it. You can imagine a gaseous planet which is very close to its own star, around 7 million kilometers only, and that star is gaseous. So what will happen to the atmosphere of that planet? Of course, the gases will be affected by the heat of that star, and it will start to escape from it. And we have this beautiful example, which is 51 Pegasi b, one of the hot Jupiters, as we call them. Another mechanism we have, which is the photochemical escape. Let's say when light comes from the outer space, and that light consists of photons. If that photons strike the atmosphere with high energy, so in the upper atmosphere, high energy like ultraviolet photons can react more rapidly with molecules, and then the gases will start to escape from the atmosphere. We have this example, and that occurs on Mars. Sputtered escape, and this mechanism access kinetic energy from the solar wind. Now we started to talk about the solar wind and its effect on the planet, which the planets which have not have no magnetic field. So the solar wind can impart sufficient energy to eject atmospheric particles like sputtered from a solid surface. This type of interaction is more pronounced in the absence of a planetary magnetosphere, and this is what we are talking about regarding Mars. Look at Mars here. When the charged particles come from the sun through the solar wind, it hits or it strikes the atmosphere of Mars directly. So by this collision, the molecules there, the gases there will get more energy, and they will move faster than the escape velocity of Mars, which is 5 kilometers per second. So they can leave easily. So you may notice now that the issue is about the two things about how the gases can escape from the atmosphere. Number one is the magnetic field. Is it existing or not? Number two, the gravity of that planet. Let's talk about now about Earth. Look at this video here we have. Look at the planet here. We have our Earth, and here is the charged particles that come from this sun on this way, but ultraviolet can find its way between the lines of the magnetic field. Once the ultraviolet or the charged particles found their way, they will hit the North Pole, for example, here. So the gases there will start to escape because it will become more energetic. Regarding Mars, Mars is completely different because it has no magnetic field. So the solar wind, as you see, struck the atmosphere or struck the entire planet without any protection there. So that we can see here the distribution of the molecules that were driven by the solar wind. Polar wind escape, we talked about that, and the effect of that, we know that near the poles of magnetosphere, the magnetic field line are open, allowing the ions or the charged particles to go through this area and then to strike the pole. Of course, this is very famous image, aurora, the effect of because of the solar winds. The solar wind can find its way. Anyway, we have also one of the mechanism, which is the charge exchange escape. Ions in the solar wind or magnetosphere can charge exchange with molecules in the upper atmosphere. A fast moving ion can capture the electron from a slow atmosphere neutral, creating a fast neutral and a slow ion. The slow ion is trapped on the magnetic field lines, but the fast neutral can escape. So it's about of collisions. So a fast ion will come to strike the slow neutral one. Then the slow neutral one will, after the collisions, will be faster and faster, then it can escape. Impact erosion. So we mentioned that before. If something happens like this, let's say meteor impact or any impact like a heavy object that might come from the outer space, if that hits the planet, the impact of a large meteorite, for example, can lead to the loss of atmosphere under one condition, if a collision is sufficiently energetic. So we have three main ways for that. The meteorite heats and accelerates the gas it encounters as it travels through the atmosphere. Number two, solid ejecta from the impact crater heat atmospheric particles through drag as they are ejected. The third one, the impact craters vapor, which expands away from the surface. And that one is the most common one for the atmospheric escape regarding this mechanism, impact erosion. So we can conclude what we have mentioned in comparison between Earth and Mars, and put in consideration the magnetic field, of course. So for Earth, some of the gases can escape under specific conditions in the absence or in between the lines of the magnetic field, as we mentioned, through the poles, for example. But for Mars, look at Mars. Mars, like, it loses its atmosphere faster than Earth because it has no magnetic field. And of course, that process happens millions of years ago when the active core of Mars shut down. And here is a comparison between the three planets, Earth, Mars, and Venus. It's the same process. I don't want to repeat it. Regarding the escape velocities that we mentioned earlier about the planet Earth and Mars. So we have here the planets. We have the escape velocity for each object in the solar system, including the sun. And we have here the amount of heat that for any gas that can receive, and then if it is energetic, if it exceeds the escape velocity of that planet, it will escape directly. For Mars, it's about 5 kilometers per second. That also is a very essential factor for the atmospheric escape. The sun plays a very essential role in this one because over time, the sun is going to change. The luminosity, for example, is going to be brighter and brighter over time. So we will receive much more amount of heat than we receive now. For example, here through the chart or the chart, we have the age of the sun. It's about 5 billion years. So over time, like 2 billion years, for example, it will become more brighter. So we will receive more from the ultraviolet, from the solar wind, and so on. So you could imagine what if the magnetic field of our planet shut down, because no one knows this dynamic process, how it happens or when it can stop. So we have many theories, many explanations about why Mars lost its active core, which generates the magnetic field. So some scientists say that because Mars is a small planet and it is far away from the sun, regarding the size of Mars and the distance between it and the sun, so the core of Mars shut down. But this one is still under construction or under study. Mars rehabilitation. The atmosphere on Mars is very stifling, as you know. It is unbreathable. Even the soil. Let's say if we succeed to find under any condition liquid water on Mars, can we use it? That is a question. Actually, we cannot, because the soil of Mars is toxic. We cannot use it. But in future, our plan, we have crazy plans to make Mars habitable for us. First, we need to travel there. Look at Mars in terms of the habitable zone. Its habitable zone is the place which through which we can find liquid water. So if we study the sun, for example, so the distance between the sun and the earth is about 150 million kilometers. At that distance, we can find liquid water, or that planet can sustain liquid water. But Mars, for example, it came at the end of the habitable zone, and that is a comparison. And this we have Kepler 22 system, one of the exoplanets, and how it lies in the habitable zone too. According to scientists, so this one we mentioned already, a region of the solar system that is the habitable zone where we can find liquid water. But now water on Mars, we can find it just under or beneath the sand or in frozen caves. The lack of both magnetic field and geological activity on Mars may be a result of its relatively small size, as we mentioned, because, as we mentioned earlier, because the magnetic field or the active core shut down, and there is no geological, there is no magnetic field, and there is no geological activity. That's why Mars lost its atmosphere. Sorry for the sound because I'm in the exhibits, so sometimes we can see, we can hear some voices. So let's talk about some, you might say, some crazy plans about how to make Mars habitable, Mars terraforming. So what do we mean by this idea? Mars terraforming is to make Mars habitable for humans one day, to not go to live wearing spacesuit, live inside domes or protective domes from the ultraviolet. No, we need to walk, we need to live normally the same way here. So we need to change the environment of Mars. How to do that? The issue is about temperature. If we can warm Mars, by warming Mars, you will release the liquid water. This is number one. Number two, you will release the carbon dioxide, which is very frozen now. By carbon dioxide when it is in the gas state, so it can make the greenhouse effect, and that one will help Mars to get more warmer. So one of the crazy plans, actually, they focused on the North and the South Pole, where they can find the carbon dioxide. So they said that let's make orbital mirrors. So we need a mirror, concave mirror, like 150 kilometers in diameter. And by focusing the sun or by reflecting the sun's heat, we can use that heat towards to re-guide it towards the North Pole, for example, of Mars, to melt the carbon dioxide there and to release it, and that one, or to generate the greenhouse effect. By this method, we will get Mars more warm than before. Scientists have considered placing, of course, like the diameter of the mirror, 150 miles, or let's say it's 150 kilometers at least, but it will cost a lot, of course. But we are talking about Mars terraforming, and that is not for the foreseeable future. This is for far future. We have crazy plans, but we must trust in our skills. We must trust in our ingenuity, and to find a way to make Mars habitable one day. Another methods and strategy, let's say we have ammonia to support Martian service with ammonia. For that, we shall need huge factories. So what ammonia, NH3, and that one will break down to nitrogen and hydrogen, and it will make the greenhouse effect. It will get Mars warmer. And of course, another one, which is, let's say, insane. When Elon Musk said, let's nuke Mars, it means let's take nuclear weapons, let's take nuclear bombs, and let's explode it in the atmosphere or the upper layers of the atmosphere of Mars over the North Pole of Mars. So we will create temperature, high temperature, and that temperature will melt the carbon dioxide there. But we have a problem with this proposal, because to use a nuclear bomb, you will create a disaster there. You will create a nuclear dust cloud, and that cloud will block the sun completely. So the surface of Mars will be in darkness, and you will make Mars more colder instead of warm it. So we cannot consider this one, actually. So we have huge factories. This is the main plan, let me say. The main plan is to create the greenhouse effect on the Martian surface. How? To build a huge factories over time, and that factories will support the atmosphere with some of the gases that cause greenhouse effect. Course, like chlorofluorocarbons and perfluorocarbon 2. That one will, these gases are proposed for introduction because they are generate a greenhouse effect thousands of times stronger than CO2 that we have. So if we succeeded to generate greenhouse effect on Mars, if we got Mars warmer, how can protect the atmosphere without with the absence of the magnetic field? This is also will be a problem. So there is an idea to create artificial magnetic field. And as you know, there is some point in between Mars and the sun where the gravity of the sun and the gravity of Mars is in balance. We call that Lagrangian point. So L1 here means Lagrangian point. At this point, if we put any object, it will orbit the sun at the same point. It will not change it will orbit the sun with Mars. So if we have the ability one day to generate artificial magnetic field, we will put a huge magnet in this point, Lagrangian, and that magnetosphere or that magnetic field will protect the entire planet. These are some references for the articles I read, for the information I got, if you have time to check it out. And thank you.
Thank you very much, Amr, for this thorough presentation regarding Mars' different physical escape mechanism, and also how can we more or less change the atmospheric composition, terraforming it, and so on, building something like a magnetic field around it to protect it from the highly charged particle of the solar of the solar wind. So now let me open the floor for questions. So please, if you have any questions, so please ask, or you can use the chat to write your question.
Before receiving your questions, I have something to add, because you may say that first let's go to Mars. This is a challenge. Now we are trying to go to Mars. If we go to Mars, then let's find a way to survive. After surviving, let's find a way to make the Mars rehabilitation again. But for the plans to make Mars habitable, you may say, like, we cannot do that one. We cannot achieve any of the plans. We cannot create an artificial magnetic field. We cannot build huge factories that can support gases of the greenhouse to make the greenhouse effect. We cannot do that one. But remember the advances we have made in the last 60 or 70 years. We, you know, that the silicon chips that powers all of the aspects of our life, we just made it 60 years ago. And no one dreamt to travel to the moon. At that time, we have just a piece of paper and no computers, no programming, nothing between our hands. But like as Stephen Hawking said, in 2600, the world population will be like 40 or 45 billion of people. So we will stand like shoulder by shoulder on the planet Earth. So with our limited sources and the hazards that we face every day, we cannot stay here on Earth watching our planet get destroyed. So we must look for the future, the far future of our planet for the next generation, to avoid extinction, to sustain our existence.
Thank you, Amr. Any question, please?
Hello, I would like to have to make a question.
Please go ahead.
Thank you. I'm teaching at the Department of Architecture, and for me, your lecture is very interesting. It's very rich, but it's very scientific for us in architecture. We are interested. I mean, me and one team of mine. I don't know if they are attending, but. We are interested in the third stage, not only reaching Mars, or not only really being there, but also how to make it architecturally inhabitable. And you have great experience about the atmosphere of Mars. I mean, I was following your lecture. It's very full of details that are hard for architects to comprehend. But I have kind of a simple question, like kind of recommendation, if I can get something from you. I always imagined the atmosphere of Mars to be full of dust. And I mean, my students are designing a building on Earth that simulates the situation of Mars. I mean, last year there were other team who are really building on Mars. But for my team, they are doing just a building on Earth that simulates the situation in Mars, and we are focusing more in the aspect related to psychology, how humans will be able to really deal with the situation of isolation on Mars, etc. However, the building on Earth need to be somehow simulating the building on Mars, and I always thought that buildings in Mars, at least in the beginning, needs to be smooth outside because of the dust and so on. Is there a way to simplify it and we say that this is true or not really? I always imagined, at least since I was a child, that all buildings on other planets need to be like geodesic domes, like those we can see with architects like Buckminster Fuller's, and later developed by many architects like Norman Foster. All these kinds of smooth, where you really isolate the building from the outer space and you create your own atmosphere beneath them. But then I was, for a while, watching competitions, and I always see strange shapes of buildings. Any comments from your side on that? Is it really, building really needs to be smooth at the beginning? I know everything is visionary. We are talking about future, far future, but as a starting point, how do you feel about it?
Thank you for the great job that you are doing with your students. This is our target, actually, to open the window for all of the let's say students to think about Mars and to try to simulate, try to find out solutions for the challenges there on Mars. So thanks so much for that. Regarding your question, you said about the, if I understood you, you told that the structure there must be curved, okay? But you saw some other which are strange. So let's say, according to what we know about Mars, why they will make the dome, for example, curved like this, to make the reflection of the ultraviolet and the radiation that will come from the sun or from the outer space easy to be reflected again, not to absorb. So the shape, that shape is the best or the perfect shape to reflect the radiation. That is what I conclude.
See, so it's not because of the particle of the atmosphere, but because of the rays. Okay, I learned.
Yeah, because as you said, they will create their own environment under or beneath the dome. Okay, so they will do that, and I think this is the first step. This is the first step to sustain on Mars. We will live on dome. That is 100% sure about that.
Well, if I may add something, whatever you built on a planet, it all depends upon the environment. As we say, the Martian environment is very dusty, and also the atmosphere is very thin. And you go there, you need Mars is further away than Earth, so you get less energies. And one point that's why in most of what we have seen as Martian habitat design, there's these glass domes and so on, because you need to get more light to your habitat, in addition to get some of that light being reflected. But in all situations, you go there, as Amr said, you're going to stay at least for 26 months to get any resupply from Earth. So you need to be totally independent. So your environment must not allow you to think about Earth. So you must have a Martian environment 100%. This is exactly what our previous speaker, we got someone from the American University of Sharjah. So he's a specialist in terms of architecture and also in terms of space habitat. This is exactly what he says. So you need to be independent from Earth. So your architecture there must be independent of Earth. It means that you need to have a new thinking about how to be something that you're going to call home for at least 2 years without thinking about coming back to Earth and so on. Amr, if you can read the chat, there's a question.
I should open the, yes.
The chat, with the 1 or 2 questions from Ahmed.
We have here the link from Ahmed. What did you find from the information you had so far? Has the Mars been inhabited before? So Ahmed, if you mean inhabited like we have, or Mars had life or potential one day, actually we cannot confirm that. But according to the data and information that have been collected for the last, let's say 30 or 40 years, we can confirm that Mars used to have a thicker atmosphere and liquid water on it. But living things, we have no sign of any living things currently, till now. But don't forget something very important. Why we want to send a human there? To dig down, to search in area that no robots can go. As you know, or you may know that there is a place there called Tharsis Mountains, and we have 3 mountains there. Then the Olympus Mountain, the highest volcanic mountain in the solar system. So in this Tharsis, we have one of the mountains there. They found 7 caves, and the diameter of these caves, of each one, like 300 to 500 meters. So, but we cannot send a spacecraft or a robot to go through the cave or to go inside the cave, because we will lose the communication with that. So if we send a human so they can look inside these caves, maybe we can find something. This is the idea. No, but Mars used to have liquid water, used to have thicker atmosphere. It was warm. This is what we know in the past, of course.
This was about 3 to 3.5 to about 4 billion years ago.
Yes, yes.
The other question, the other question from Bashair.
Yes, Bashair, in how many years do you think we will be able to visit Mars easily? Let's say within 10 years, we will land on Mars from now. And now they are working on it, either NASA or Elon Musk and the private space companies. But to travel easily, like to go and come back, and I think it will take like 100 or 150 years. And do not forget that UAE has a very bright project to colonize Mars and to build a city there by 2110 or 2120, I think. So we have a plan here, but it is a long-term plan, we know, but the work to achieve that plan started 5 or 6 years ago. So it is a great plan. We should prepare ourselves for it. Thank you, Bashair. Hopefully I answered.
Yeah, we have a still long way to go to Mars. We have sent so many spacecraft, but to send someone there. So first we need to think about the moon, the Artemis program, of which will be successful. It may take us a couple of decades to send a human to Mars because we don't have now the right technology. The main setback is time. So you need at least 6 to 7 months to go to Mars. So and for one-way ticket, and that's quite a long time. We don't understand how those space affect our bodies. We have the ISS station. We have all of this experiment done on the astronauts, and the conclusion that space does affect our bodies. So as long as we don't understand that very, very well, so it will be quite dangerous to send someone to Mars. But for now, the bottom line that we don't have the technology to do it, period. It will take a lot of time. Okay, so thank you very much all. Thank you for all the attendees. So we appreciate to be with us every time we have a program. This is the last lecture of this 2021 year. So we are just about 1 week and a half from the 2022. So hopefully we get yes. So hopefully we get new and exciting programs. And if you would like us to present something, so you can email us. So please, we'll be more than glad to see how we can manage to give a look to that you would like us to talk about it. So we are very open to suggestions. We love to have your comments. So please send us an email. Our email is very, very simple. Go to our website and you get everything from it, inshallah. So thank you all for attending, and see you next time. Thank you very much.
Thank you. Thanks so much.
Thank you, Amr.
Shukran. Shukran. Thank you.
Thank you.
Thank you very much.